Alright, so this video is going to look at more organic molecules, but we're going to look at them a little differently. Now we're going to look at them with what we call polymers. So what are polymers? These are extremely long molecules made up of monomers. I know, very helpful definition. So what does poly mean? Many. And mono, one. So monomer means single unit, so one unit. And so a polymer is a long molecule made up of a bunch of these monomers. Okay, so these monomers can be individual units, or they are individual units, sorry, but they can be made up of as little as 4 atoms up to 100 atoms. So they can be very small or they can be quite large. Just depends on what we're trying to build. And our polymers can be either natural or synthetic. We're going to look at both. A lot of the focus is going to be on synthetic because that is what we've been doing a lot of. We've been doing a lot of synthetic polymers. So synthetic polymers are commonly known as plastics. So that's actually their common name. And they have a wide variety of uses. In fact, if you just look around where you're sitting, my guess is that you can probably count at least a dozen things that are made out of plastic, if not more. You're likely even wearing something that's made out of plastic, that's made out of a synthetic polymer. So we have these guys all over the place. And as far as materials, we now use them more than steel in the United States for building materials as far as like cars and things like that. So they're very, very versatile and useful materials. So what we're going to look at is we're going to look at how we put these guys together and then look at different examples of these synthetic polymers and then natural polymers. So first thing to talk about is how do we create these polymers? So we're going to get our monomers. So we need to create those monomers, whether it's that we extract them from crude oil, or if we create them, because some of them we do need to create. But one way or the other, we get our whole hands on the monomers, the pieces that we want to put together. And then there are 2 ways that we can put these guys together. So the first one is what we call addition polymers. So addition polymers, these guys are where we have the monomers put together because the monomers have a double bond in them. So there's a double bond somewhere in that monomer, right? So we saw in previous videos that very often we'll see, for example, carbons that have a double bond and then, hydrogens out here. That's what we're talking about. So the monomer has to have this double bond somewhere in the molecule. Because what's going to happen is you're going to break that double bond and form a new covalent bond in the polymer with it. So this won't exist anymore, and this will be replaced with a single bond, and then that bond, the other single bond, will be used to make a new covalent bond in the polymer. And I'll show you what that looks like here in a couple slides, I promise. So that's an addition polymer. So addition polymers are where you just move the bonds around to be able to put those polymers together. This is different from what we call a condensation polymer. So a condensation polymer is where we put those monomers together by removing small molecules. Commonly, it's going to be something like water or hydrochloric acid. So you know that you're looking at a condensation polymer if you have either H2O or something like HCl coming out when we put them together. So up here, nothing's going to come out of putting those bonds together. Here, we're going to have to remove material in order to make the bond. So, to be able to do this, those monomers have to have functional groups. So they're going to have something that we saw in one of the previous videos. They're going to have a hydroxyl group. So they're going to have one of these guys on them, or they're going to just have hydrogen. They're going to have one of those guys on their end in order to be able to be joined together. Because this, well, I just happened to write them, these two are what will be able to react together to be able to take the water out and make the bond in between. So, all right, so let's take a look at just some examples of polymers, synthetic polymers that we make with each of these methods. So up here, these guys are all addition polymers. So we've got polyethylene, polypropylene, polystyrene, polyvinyl chloride. You may have caught on that their names have to do with the molecules that we build them out of. And so you can see here, we're joining these different molecules. These are their base monomer. So this is the unit that's going to repeat. We're just going to stick a bunch of these together. Again, they originally have a double bond in them. The double bonds have been removed. And you can see what kinds of things we make out of these addition polymers. We're going to look at these in a little more detail. Condensation polymers, you can see these guys have much bigger names. These are going to be more complicated because these guys have more complicated structures in order to have those functional groups. So you can see here, these guys have things like the oxygens on them. They have the nitrogens like the alkaloids. They're going to have those functional groups that you saw in that previous video about, well, the previous videos about functional groups. So I told you I was going to show you how something like an addition polymer worked. So here you can see there's that guy actually I drew on the previous slide, double carbon bond. So these bonds will move to join on either side. So you can see that the electrons are here now because that bond has been taken out. There's still a single bond between the carbons. And now when these guys undergo polymerization, being made into a polymer, here are the new bonds that replaced that other bond in the double bond. Okay, so that is, this one again, this is the addition. We'll see on another slide later how the condensation one works. I went ahead and just left that so we can look at it later. All right, so let's take a look at some of these examples that we just saw in the previous slide in a little more detail. So the first one we're going to look at is polyethylene. So polyethylene, there are two types. So we're going to see these guys. You can see them right here. HDPE, LDPE, PE for polyethylene. And they are made because they're still the same polymer. So they're both made out of polyethylene. So poly for the polymer, ethylene for the monomer that was put together. But the strands are going to actually be formed into different configurations because of the catalysts. So you can see here, HDPE, the strands are in these more organized, long strands, and LDPE, they're more branched. And so let's take a look at what that does. So HDPE stands for high density polyethylene, and that should make sense that it's going to be rigid and tough. So this stuff, if you put it in boiling water, I don't know, some people do. No, actually, some of the things that you would use this for, you would need to put it into boiling water for maybe disinfection purposes. And so if you take HDPE and put it into boiling water, it won't change its shape. It may get a little flexible, but it's not going to shrink or anything. So very tough, rigid type of plastic. And that's because of these strands being in these long strings, and they kind of go back and forth. They cross back and forth, but in those long strands. So they're going to kind of go this way. Okay. So what do we use HDPE for? This is what milk jugs and water jugs are made out of. So, you know, that standard kind of not clear plastic, but the kind of foggy plastic that you'd have a milk jug made out of. And then bottle caps. So like bottle caps from, sorry, I thought I had the bottle closer to me. So like one of these water bottles, this bottle is made out of a different type of plastic, but the hard cap that you've got on it, that is going to be made out of HDPE. So that's why a lot of recycling programs tell you to take the caps off of bottles because they can't actually be recycled together. All right. So LDPE, low density polyethylene, this stuff is going to be flexible and bendable because the strands aren't close together. You can see the branching pushes them apart, and so there's more space between them, makes it very flexible. This also, though, makes it so that if you drop this in boiling water, it's going to deform. It's going to shrink, it's going to bend, it's going to actually put holes in it. And this is what you are going to have your plastic wrap, your Ziploc bags, that kind of thing, trash bags. They're going to be made out of LDPE. This is why it's a good material to make something like trash bags out of, because it allows it to stretch to a point before it breaks. This is also why, though, you can't take a zip bag and put something in it like, you know, boil in a bag type rice and put that in boiling water, because the bag is just going to break. If you look at the boil in the bag rice, the bag is actually going to be a plastic a lot more like HDPE. It's going to not be clear. It's going to be kind of that foggy color because that stuff can hold up to the heat. Right. Our next one is polyvinyl chloride. You've probably never heard it called polyvinyl chloride. It's PVC. Polyvinyl chloride, its monomer unit is hydrogens and carbons, but there's a chlorine on each monomer, hence the polyvinyl chloride. This stuff can be made into rigid or flexible versions depending on how it's catalyzed together. And it is used for all kinds of stuff. PVC is all over the place. We just don't realize it. The one that we most commonly are thinking about when we think about PVC is pipes, right? You think of PVC for water pipes and so forth, but a lot of the doors, like especially exterior doors and window surrounds, are actually made out of this. There are some bottles made out of PVC. Your bank cards and ID cards are made out of PVC. And then imitation leather, of all things. So yeah, PVC is actually all around us, and is not one of the synthetics that is really recyclable. And I also put in here the picture of shower curtains, because shower curtains are also made out of polyvinyl chloride. So you can see the very wide differences in how you can put together one of these synthetic polymers. Our next synthetic polymer is polystyrene. Styrene for its monomer. It looks different this time. Instead of chlorine or something like that, we actually have one of these hydrocarbon rings, one of these what we call benzene rings. That's why it's got styrene for its name. And you might be looking at these cups going, well, the only one here that belongs to this group is this one right here. Okay? But here's the thing. Polystyrene can be made into transparent material. Actually, all of these cups are polystyrene. If you look under all of these cups, they're going to have the same recycling number, that little recycling symbol with the number in it. That's because they're all made out of this same monomer. The difference between them is that this one has the common name of styrofoam. And that's because when they form those ones, they blow gas into the liquid form to create the foam, to create that extra insulation. Otherwise, these are all identical. And so that's what creates that styrofoam material. But it is a synthetic plastic just like these kinds of cups are. All right, I'm going to pick up in the next video and finish up with the synthetic polymers and then talk about the natural polymers.